Hello, and welcome to one more English lesson, right? Our science class. So I wish that everybody enjoys this lesson, right? Okay, and I hope that you have been having a good day. Okay, so thanks for being here, firstly, right? And let's go on what matters, right? I don't know if you can listen, but today we have this song in the background, but of course I'm just gonna put that. When I'm not really making any deep explanation, right? Okay, but that's a song that I like. It's really relaxing. Anyway, so just follow me. Yeah, let's go on. Science class, science English class, which means that we're gonna learn that using English. And today is the final part, is the last part of section 7. Okay, which is summary questions for section 7, which means questions. Yeah, like we have been studying section 7, and today we have a summary. Yeah, we have these questions about, and let's see if we have learned that, right? So check it out here. So this is section 7, right? I'm gonna make it a little bit bigger, okay, just a little. I'm gonna move myself here, down here, okay? So I'm gonna read the questions, and then you guys can follow me, okay? So let's go on. Follow me, read with me. Summary questions for section 7. These sections got loads of information about the different properties that materials have. These properties determine what jobs a material can be used for and how mixtures of different materials can be separated. Make sure you know the difference between reversible and irreversible change too. Then have a go at these questions and don't stop until you can answer and all. This "and" basically means then all, okay? So that is the meaning here. I hope that you understood what is being asked here, okay? Just for a matter of help, okay, let's say like that, I'm gonna read this question in Portuguese for you, just for you to make clear that you get what we are doing. So this again, let's read again. This section's got loads of information. Esta seção tem muitas informações sobre referente às diferentes propriedades que os materiais têm, materials have. Essas propriedades determinam qual o trabalho que um material pode fazer ou ser utilizado para, e como essas misturas de materiais diferentes podem ser separados, can be separated. Make sure, então tenha certeza que você conhece, que você entende, que você sabe a diferença entre os reversíveis e não reversíveis, ok? As mudanças que os materiais reversíveis e não reversíveis, pode ter também, too, ok? Então, have a go. Então vamos dar uma olhadinha nessas perguntas e não pare até que você responda todas elas. É isso, ok? Em português, that's it basically. So let's go on. Let's go down here. What I'm gonna do, I'm gonna read the question. Sometimes I'm gonna give you a fresh reminder, right? Just a friendly reminder. It's okay, this question was about that, so you can see that on the previous page, okay? But just to make it clear for you, all the answers from these questions, you can find them on this section 7. So go back on the pages before and then check it out there, okay? So let's read, let's go together, okay? And of course, I want you guys to really pay attention on the way that I make the pronunciation so you can practice together, okay? So let's go. I'm gonna make it a little bit bigger. Sorry guys, just a little. Okay, I guess no problem, right? So let's go on. Question number 1. Complete this sentence. Glass is used to make windows because it is what? If you don't know, go back on the page before, okay? Number 2. Which of these properties of steel is important if you are going to use it to make a spoon? I'm going to make a spoon. So Which of these properties of steel is important? It's like magnetic, it's opaque, it's insoluble. If I'm going to make a spoon, do you remember what is a spoon? We use it to have soup, for example, okay? So which of these properties of steel, right? Again, properties of steel. So I hope you know what is the meaning, because if you don't know, it's going to make it difficult for you to understand that. Again, if you don't know, go back on the page before, right? So is it A, B, or C? 3. Which is true? Which one? Yeah, like which one is true? Heat can travel well through all materials. Or heat can travel well through some materials. I mean, heat. Teacher, I don't remember what is heat. Go back on the page before, right? So we are talking about heat here, okay? So it can travel well through all materials. I mean, it doesn't matter what kind of material I get. So the heat will travel through this material with no problem. I mean, easily. Is it true or false? Or it depends on the material. So answer that for me, right? Changing. Let's go. On 4. Let's go on here. True or false? Metals are good thermal conductors. Metals are good thermal conductors. True or false? Do you remember? Number 5. What is a thermal insulator? What is a thermal insulator? Remember insulator? Like it kind of protects the material, doesn't let some things go through it. Do you remember what is that? So what is that? What is a thermal insulator? Explain that. Explain that in English. Okay, so remember, this summary question here, okay, these answers that we are having here, you have to answer them in English, not in Portuguese. In English only. Got it? Let it go. Next one. 7. Can electricity pass through wood, metal, or plastic? Which one electricity can pass through? 8. Why are electrical plugs made of plastic? Why? What is the reason? 9. Why is it a really bad idea to touch an electrical switch with wet hands? Take a look on the words. Switch with wet hands. So pay attention to that. Wow, we have a lot of questions, right? Next one. 10. What is the only type of material that is attracted to magnets? There is only one type of material that if you put a magnet close, it will attract. What is that? 11. What is a solution? What is a solution? Explain using English. 12. What happens to sugar when you add it to a cup of tea? What happens with sugar? It disappears? It doesn't? So what is the point? 13. Which 2 of the solids shown below are soluble in water? And what is soluble? Do you remember the meaning of that? So we have this 1, 2, 3, and 4. Okay, two products, okay, are soluble. Which one? Is it sugar? Is it nails? Is it stones? Is it salty? Teacher, this is nails? Yeah, nails. The same as our finger, right? So we use the same name, right? Okay, this is nail, right? And the picture here is also nail, right? Very good. Going down. 14. What do you call a solid that does not dissolve in water. What do you call? What is the name that we give to a solid that does not dissolve in water? Teacher, I don't remember. Go back, right? On 15, how would you separate the gravel out from a mixture of gravel and glitter? Teacher, I don't remember what is gravel. I don't remember what is glitter. Go back there, okay? Go back and check. 16, how would you separate the salt out from a solution of salt and water? I mean, we have to do something with the water, right? What is that? So, 17, you mix some sand with water and then filter the mixture. What passes through the filter paper and what stays behind in the filter paper? Yeah, if we mix sand and water and if we filter the mixture using like a filter paper, I mean, both materials, they will not go through the filter, right? One will go, another one will stay because it's bigger, it's thicker. So explain that. 18, if you evaporated some water by heating it, how could you turn it back into a liquid? So what do we have to do to make it back? 19, give an example of any change which cannot be reversed. So give an example of a change. Okay, teacher, if you do this to that, it is impossible to make it back to the state it was before. So that's what you have to explain. Give an example. 20, write whether each of these changes is reversible or irreversible. Teacher, this weather is like storm, rainy, sunny. No, this weather here works like, I think the best synonym word is like if. Okay, do you know if? In English, I think it's easy, right? So write if each of these changes is reversible or irreversible, but what is the same meaning? Okay, so burning a wooden log. If you burn a wooden log, teacher, I don't remember what is a wooden log. I have already explained that. So go back on your book, check the lessons before. If you do that, is it reversible or irreversible? And when I say reversible or irreversible, I mean if you burn a wooden log, right? So it will change, yeah, like the state of the wood will change. So if I want to make it back, burn and after like unburn that, I don't know, there is no word for that, but to make the ashes, yeah, like the result of the burning, if I want to transform it back into a wood log, is it possible? Yes, no. If yes, it means that the material is reversible. If it's impossible, is irreversible. Okay, so answer that, and if you can, explain why you can or you can't. Explanation has to be in English, right? Coming back, let's continue. B, cooking an egg, reversible or irreversible? Boiling a pan of water to make steam. D, melting iron in a blast furnace. E, adding vinegar to... Oh, that's... Let's listen to this pronunciation. Listen to...
Bicarbonate of soda.
So adding vinegar to bicarbonate of soda. That's the thing, yeah? I mean, you know that in Português, yeah? Bicarbonato de sódio, ok? Se você não sabe, pode perguntar para mom, né, pro daddy. This is a product that normally adults use, okay? So if you do that, if you add vinegar to bicarbonate of soda, so is it possible to reverse it, to separate them back, or no? And F, the last one, dissolving sugar in water. If you do that, is it possible after to separate the sugar from the water, or no? So what do you think? All these questions here that we have seen, yeah, that we have read, okay, from section 7, you must answer that in English, okay? And of course, you should use your own English to answer that. You're gonna write it down on your notebook Then you're gonna send me the picture so I can check if you did that well or not, okay? Try your best. If you have questions, you ask me, teacher, can you help me? I don't remember, I don't know, I don't understand that, okay? Basically, this is the first page of the day and the first homework of the day. So let's go to the second part. Okay, so after finishing, right, the summary questions, the questionnaire, we begin a new section, a new unit. Section 8, forces and magnets. We know that word, right? Magnets, that thing that we use on the refrigerator, yeah, to stick things on the refrigerator door. Okay, and let's take a look on that. Let's see what we can get from that. Okay, forces. Let's begin here. I can't force you to learn any of this. For sure I can't, right? What is a force? What is that? So let's check it out here on some samples. A force is a push or a pull. Forces can make things, number one. So let's see some examples of what force can make things do, for example. Number one, speed up or start moving. So this idea of force, yeah, when we talk about force, means force can push things or pull things, yeah, on the space, right? Make it move ahead or make it move back, yeah. Speed up, make it faster. Start moving, make it have like has, right? And motion, right? Movement. So that's number one. What else force can do? Can slow down or stop, for sure, yeah. We have here the example of a car, right? A very fast car, and then when we have this giant paragliding behind, right? So when you open that, of course, this force will stop the car, right? As we have in the first one, there is a spaceship, right? There is in the first picture, yeah, and because of the force on the back, yeah, we can see the fire, right, on the ship, on the, it moves it, right? Number 3, force can change direction, yeah, can change direction or direction, like a car. If you're driving and then comes something, if you force, yeah, the wheel to the other side, it's going to change the direction. And number 4, can change shape. Oh, really? By gum. Look at the stretch on that. This word gum, G-U-M, is like babalu, yeah? Or is what we call in Portuguese, yeah? Gum is the Portuguese version, right, of chiclete, okay? So basically, that's the thing. All right. So we have seen here some examples of what force can do, right? By the picture. So there is a gun here, and then because she's putting force on that, yeah, so it's stretching, okay? So these are some examples of force. So I think you get it, like the force. So for example, like imagine I have this paper, right? Okay, it's a tissue. So if I force it, like, yeah, it's gonna change the shape, like has pressure. So basically, force makes things move. Yeah, ahead, back. Force can have actually many effects. Yeah, on the things that we have here in reality, right? Material things. So I probably have seen that in science class on your school. If you haven't, so here we do, okay? So we're going to check it out a little bit. Yeah, of course, we're going to go deep into that, but just to have an idea. Let's go on. And coming back to the page, right? Okay. We have some explanations here. Can you see that? So, most forces need contact between objects. You need to touch the object so you can apply the force, yeah, so it can have some effect. And we have 2 pictures here. So let's analyze this first one here. It's like a boy, girl, I don't know, hitting the ball, right? So contact with the player's head makes the ball change direction because the player's head put force on the ball and then change the direction where the ball was going to, right? And next one, elephant. Contact with the elephant slows the bike down, right? The bike was like coming behind the elephant like very fast. And then when it hits the elephant, it slowed down, yeah? I mean, right away, very quickly, right? Especially because the elephant has a much bigger force than the bike, right? And going down a little bit here, right? Let me get this. I think you can see that, right? By magnet force, let me make it bigger. Just a second, guys. Okay. So follow me. But magnetic forces can act at a distance. Oh, really? So, I mean, we have different kinds of forces. Example, magnetic forces. And it doesn't need to touch to have effect. So let's see. To act, actually, right? Magnets don't need to touch objects for a force to occur, to happen. So there is a picture of this man and he has a magnet here, right? This is the magnet. And then this is the magnetic forces, right? Here, and we can, like, of course it's invisible, right? But here it's, I mean, it's presented as a picture, right? It's a draw. And then here we have the magnetic materials, yeah, the clippers, right? So because they are made of, like, I don't know, aluminum or iron, whatever, and then magnet attracts it. So of course you don't need to touch. Only the fact that you put it closer, it will, you know, like, it will force them near the magnet. They will come here, all right? They will pull, okay? It will be pulled towards you in your direction, yeah? The force will moves it in your direction. So basically, these are some examples, yeah, of what kind of forces we have in reality, yeah, in our world, in the place where we live, and how we can identify that. So these are some very simple examples. I mean, not so complicated, is it? So let's move on. Let's continue. Okay, so now let's take a closer look on magnets, okay, and how they work. So follow me. Magnets exert a force on other magnetic materials, okay? So it exert a force. It has that kind of force that makes them be attracted, right? So of course they need to be magnetic materials, okay? So actually, let's listen how the magnetic, let's listen how the native people pronounce that. Magnetic, okay, and magnets. So let's listen to magnet. Yeah, it's the same. So number one here, so we have some samples of the North Pole and the South Pole, I mean the sides of the magnet, right? And how it works. Yeah, we have six explanations here, okay? So let's go one by one, okay? First one, a magnet has a North Pole N and a South Pole S, okay? So this is the way that we recognize them. Okay, so that's the first thing. This is the first thing that we should analyze. North and South. 2. A North and South Pole attract each other. So the North and the South, yeah, they attract each other. I mean, if you put them closer, they will get together, right? So what does it mean, teacher? Which means that if you have a North here and a South here, and if you put them a little bit closer, they will attract, like they will make this like that. I mean, this is how a magnet works, right? And moving on. Number 3. By the way, yeah, just to confirm, number 2, magnets move towards each other. 3. 2 North poles repel. Again, repel, okay? Repel each other. So if attract makes them closer, repel makes them go far away, yeah, each other. Okay, you get it? Example. Let's see. Again, I have a south, I have a north, they get closer automatically. But if I have north and north, if I try to put them closer, they will like force them apart. So it's the opposite, you know, it's the opposite effect, basically. Next one. That's why we have here. Magnets move away from each other because it's north and north. Number 4. Let's see that. 2 south poles repel each other. The same effect. The same effect. If you put 2 south, the magnets move away from each other. The same situation of north and north. So basically, if you put similar poles near each other, they will force them away. They will not be attracted actually, but they will force them away. That's why we use the word repel. Okay, teacher, I don't know what is repel. So let's listen to the pronunciation one more time.
Repel.
Repel. Okay, so listen to me. Explanation. Repel. If something repels you, you think that it is extremely unpleasant and you want to avoid it. You want to be away from that. Okay, so repel means you can't be close, like it forces you away from. You need distance, right? So that's repel. Moving on. 5. Both, either end of a magnet will attract magnetic materials. So if it's the end of north or if it's the end of south, yeah, only one side, of course, right? If you put them near magnetic materials made of iron, for example, you know, like or spoon, okay, so they will be attracted, like they will be like brought closely, right? It's an attraction. And number 6, only some materials are attracted to magnets. Not all materials are attracted. Not all, okay? So this is good because you're gonna it will make a correction, yeah, of something that I said before. I said maybe it's made of aluminum, yeah, or we have 2 ways to pronounce that: aluminum or aluminium. Both ways are good in English. I guess one is more British, one is more American, but what happens here is that we learned that aluminum is not attracted by magnet. Okay, so it's only, let's see, right? Let's check it out. So aluminum, it's not attracted. Okay, so just to make it clear. And so here, number 6, only some materials are attracted to magnets. Example: steel, good. Iron, good. Brass is not. Aluminum or aluminium is not, and wood is not. So here only steel and iron, which means not all materials, yeah, not all kinds of metal are attracted. Okay, steel and iron. Teacher, I don't remember what is steel and iron. Check it out on your dictionary, right? Okay, and just to give you an idea, right, about the word iron, not actually steel, yeah. For example, do you know Superman? Yeah, there is a movie called, yeah, Superman, the Man of Steel. So if you know in the store, right, what is Superman made of, you know what is steel. So check these words for me in the dictionary. Okay, so these are some very important features, aspects, information about how magnet works, yeah. And it's very important for you to memorize that and, of course, be able to speak, to explain that in English, okay? So this is what we have of this topic now, okay? So I'm just going to go back quickly here. So this is up to number 6. So I hope you have understood that, all of them, right, that we have read. If you have questions, just ask me, right? Not a big deal. And let's read the last part here, okay? I'm just going to read it for you, okay? As I have already given you the summary questions to answer, so you have a lot of homework. So I will not ask you to translate to this last part here, okay? I'm just gonna ask you to listen to, and then I explain that you're gonna read once in English and then secondly in Portuguese. So just pay attention. North and South are friends they stick together. Yeah, I always remember the rule for two magnets as opposite poles attract, like poles repel. Nice and simple. Don't forget that not all materials are magnetic. A few metals, like iron and steel, are, but most things like wood, plastic, brass, aluminum, badgers, aren't attracted to magnets. Okay? So, quickly explanation to you. O norte e o sul são amigos, então eles se juntam, né? Eles são colocados juntos ali. Eu sempre me lembro da regra aqui para dois magnetos como. Essa é a maneira que eu me lembro dessa regra. Está escrito aqui. Opostos, né? Polos opostos se atraem. Assim como, né, os polos também se repelem, se distanciam, ok? Ok? Like poles repel, ou seja, polos iguais se repelem, polos opostos se atraem. Essa é a regra, né? Ok? Opostos se atraem, iguais se repelem. Não funciona para tudo, anyway, right? É legal e simples, fácil e simples. Don't forget, não se esqueça que nem todos os materiais são magnéticos, ok? A few metals, poucos metais. Por exemplo, ok, se eu traduzir isso aqui, iron and steel, eu vou estragar o que eu pedi para vocês fazerem ali atrás. Então, please, ok? Então, por favor, pay attention to that, right? Muito bem. E continuando. But most things, mas a maioria, como madeira, plástico, né? Esse brass, aquele que parece bronze, né? Tipo alumínio, esse badgers, eles não são atraídos para coisas magnéticas, né? Agora vamos lá. O que é esse badgers? Okay, so some simple explanation for badger, right? Okay, so this badger, of course, if we Google that, what's gonna appear is an animal, okay? But I mean, in that case here, it's a description, né, of some kind of material, um tipo de material, ok? Provavelmente algo parecido com algum tipo de ferro, alumínio, alguma coisa do tipo, ok? Mas só para você ter uma noção, right? So, these kind of materials, they aren't attracted to magnets, okay? So, basically, this is what we are supposed to learn today. So, did you get that? Did you understand? I hope so, actually, okay? So, please, right, if you understand, yeah, these are the pages that we have worked today, right? The explanation of magnets. Let me go back a little here, right? Okay, so if you don't understand, if there is something that teacher, I don't know, like I didn't understand that very well, I mean, ask me for sure, right? That's why we are here. And we also had like the summary questions, right? I hope you remember that. I'm gonna just share with you very quickly here. Yeah, the summary questions. So answer all of them. Thanks a lot for your time. Thanks a lot for for being here, right? And of course, I see you next time. Have a very good day. Thanks a lot for your help and see you soon, guys. Bye bye. Take care and see you next time.